So I know some of your classmates already posted their solutions and stuff, but I figured I'd go ahead and try to give a more detailed verbal explanation to kind of go along with it, right? So you can kind of treat these just like you do equations, right? You want to get the A kind of by itself, right? It's just that the A happens to be a matrix, so we got to be careful about some of the rules, but we can subtract 3A from both sides, right? And that means that we get a 2A minus 1025 and a negative 7261. And then I would add this matrix to both sides, right, because that's going to give us the 0 matrix, okay, on the left-hand side, leaving us with just the 2A. Okay, and on this side, if I subtract those, because remember that's a negative, we just, what's that going to be? Negative 7 plus 1 would be negative 6. Negative 2 plus 0 is negative 2. Negative 6 plus 2, and negative 1 plus 5. Okay, and then if we want to get rid of the 2, well, we'll just multiply both sides by a half. Okay, and that leaves me with A being negative 3, negative 1, negative 2, 2. So you treat those just like you do an equation. It's just that if you try to divide by a matrix, don't do that. Okay, you got to multiply by its inverse, like I said in one other video somewhere. So this one, and I know I'm leaving the other ones up to you because they're very similar. Okay, so you can go back and try them and make sure you can get it. If you still have trouble, let me know. Same thing, I'm going to work with this one here. Okay, so the I3, it's just the 3 by 3 identity matrix. So that's this matrix here. Okay, so 6 times that then, well, you just multiply each of the entries by 6. So you wind up with that matrix, and that's really supposed to be a 0, not a whatever that was. Okay. And so now the A minus the 6I3, take the 4, 2, 3, negative 2, 6, 2, 0, negative 2, 2, and then we subtract from that this matrix. That's a 0. And remember, when you subtract matrices, you're just subtracting the each corresponding element in there. So 4 minus 6 is a negative 2. 2 minus 0, 3 minus 0, negative 2 minus 0, 6 minus 6 is 0, 2 minus 0. Okay, so all I'm doing is I'm going to just, in order. 4 minus 6, then 2 minus 0, 3 minus 0, 2 minus 0, 6 minus 0, 2 minus 0. Now for the last row, we get 0 minus 0, okay, which would be 0, and then the negative 2 minus the 0 over there, and then the 2 minus the 6 would be the negative 4. Okay. And then do a similar thing for 2I3 times A, except then you're just going to multiply the two matrices together. But a nice little trick on that one. 2I3A. Okay. Well, anytime that you multiply matrices, you can always, as opposed to this, okay, we do have what's similar to an associative property. It's not really the associative property, but it's similar. And so the nice thing is that anytime that you multiply the identity matrix by anything, you just get that same matrix back. So that this I3 times A boils down to just being A. So then it's just multiply all the elements in A by 2. Okay, so that's a little bit quicker than trying to do all of the matrix multiplication stuff. All right, hope this helps a bit.